4.3 integrated math superstars. Hope you're having a great day. I know I am. I showed up a little late. My coffee had spilled at home, but you know what? I'm going to just grind through it, keep on moving. Hopefully you're doing well. 4.3 has us solving literal equations, literally. What is a literal equation? It's kind of an equation like this that may have more than one variable in it. In this case, this is a similar context than to what we've seen before, where we just have to solve for x. We've done this a ton. Now, however, when we solve for x here, this is going to provide a number. We'll soon see that that's not always the case. So literal equation is really just another way to say it's an equation with several variables in it. In this case, we only have one, and this is pretty much just telling us to solve for x. We've done problems like this before in 4.2, I believe. So we're undoing the equation. I see this fraction, so I'm going to make a note here that I see division. So how do we undo that? Hopefully you're saying using multiplication. So multiply both sides by 5. 5s would cancel. This leaves us with 3x plus 2 equals 7 times 5, which is 35, staying alive. And from here, this is a two-step equation. So use SADMAP to solve it, where your first step's either going to be using subtraction or addition. In this case, the 2 is kind of holding x back, so we want to get rid of that. So I used subtraction here. I'm left with 3x equals 33. I can then divide by 3 because 3 is multiplying with x. So here I see multiplication, but I undo it using division. Same thing over here. I see a positive term, so I undo it using subtraction. And of course, we're using this on both sides. So x is going to be equal to 33 divided by 3, which is 11. Lo and behold, we've solved for x, and we're done. So x is 11. X is isolated. It's equal to some number. Makes sense. We could plug it back in if we're not too sure if it works, but it's going to work. Trust me on that. That's the first one. Same thing here. Pretty much the same moves. However, what's different here? We now have y to cater to, but that doesn't hold us back. We're still trying to solve for x. So luckily, this is going to be pretty much the same steps as before. Multiplying by 5. 5 here. We're left with now 3x plus 2y equals 35. We've already solved problems like this before in the 4.2 quiz. I think you had something awfully similar. So move 2y over. 3x drops like it's hot. 2y is gone. 35 minus 2y, I'm just going to leave that as is because 35 doesn't have a y term with it. I can continue to divide by 3 though. So x is now equal to 35 minus 2y, and all of that's divided by 3. So this is my final answer here. Pause the video, take a screenshot, write down notes if need be, if you missed this one. We'll go from there. Same thing here, but slightly different because we see that 5 is not in a fraction. So I'm actually going to be adding 5 because x is kind of buried up here in this fraction. So I'm going to take care of everything on the left side that's not the fraction. This leaves you 4x over 3 equals 16. You have a few approaches you can take here. You could use reciprocals, but I'm just going to play it safe this time around. Multiply both sides by 3. We're left with 4x equals 3 times 16, which is 48. What can we do from here? This step's super simple. Hopefully you're saying divide by 4. this is going to say that x equals 12. And you're done. So notice that this gave us an answer, whereas on the previous slide with y, we had y along for the ride. So be open to those situations. Oh, now something slightly different. Let's see if our steps change up here. We're still adding 5, but now it's 5y. We're still left with 4x over 3. And this now equals 11 plus 5y. We're still going to get rid of our fraction and multiply by 3. And I think right here is where I see students trip up. So no doubt this is going to get you 4x. And you have some options here, honestly. So you could leave this right side as 3 parentheses 11 plus 5y. I'm okay with that. If you want to distribute in, by all means. But just to wrap this one up, I'm going to divide by 4 on both sides. And then lo and behold, I'm done. So all of this is equal to x. But if you want to distribute, that's another option. Distribute 3 to 11 and get 33, 3 to 5y and get 15y, where all of it's dividing by 4. So that's another option. But if you wrote this, I'm okay with it. Both of these work just fine. We still solved for x. What's up with this? We've seen problems like this before, and I've seen a lot of students make this a little bit more complicated than it needs to. I've seen students distribute, but there's another way we could solve it using what we call the reciprocal, where if we have the fraction of 2/5, the reciprocal is really that, but just flipped. So instead of 2 over 5, it would be 5 over 2. So this reciprocal allows us to break down fractions even quicker than before. And I'll show you why. So I want to break down this fraction and get rid of it. And if I multiply both sides by the reciprocal, we soon see that our 5's can cancel, our 2's can cancel, and then we have a pretty clean view of just x plus 3, where on the right side, 6 is multiplying with 5 over 2. Just multiply across. You can rewrite this as 6 times 5, which is 30, 1 times 2, which is 2. So the right side, I'm just going to rewrite as 15. And then pretty simple, just subtract 3. Subtract 3. X equals 12. So lo and behold, if we have a fraction that's holding us back, our reciprocal, so the flipped version, maybe I'll show you flipping of it. Because if we flip 5 over 2, we get 2 over 5, which was the fraction here. The whole idea of the reciprocal is to flip or get rid of the fraction. So our reciprocal allows us to get rid of a fraction just one move. Notice, I didn't have to multiply both sides by 5 and then divide by 2. I pretty much just let the fraction do it for me, which I think is a pretty slick way to break through these problems. So I would pause this, copy these notes, make a note of what the reciprocal does for us. That's super helpful. Keep it going. Same thing, solve for x. I'm going to use the reciprocal again. See how that goes. So multiplying by 5 over 2 here and here. 5's cancel, 2's cancel. I'm left with x plus y equals 15, like we said before. Get rid of that y. X is now equal to 15 minus y. And I'm done. Still solved for x. Still use the same steps for the most part. Deducting y was a small change, but nothing we can't handle. And I think this is approaching the last few. So solving for x here, this is going to take some time. And it's nothing we can't handle. Personally, when I look at this, I see that I have parentheses and a term on the outside. So I'm going to distribute 2 times 3x gets us 6x. 2 times 4 is positive 8. And all of this equals 4x plus 12. And so we've seen these types of problems before where we have variables on both sides. So I think the game plan here, I'm going to write this out, our game plan. Pick which side we want variables on, and pick which side we want constants or the other miscellaneous numbers on. That's your game plan. I would think of that every time you come across a problem like this. So I'm going to have my variables on the left. So I want variables on the left. You could have had them on the right, but since 6x is bigger than 4x, I'm going to put variables on the left. And I'm going to put constants on the right. Okay. So that would imply I need to move my 4x to the left. And I have to move my 8 to the right. 6x minus 4x leaves us with 2x. These 8's cancel. 4x cancels. 12 minus 8 is 4. Keep it going to divide by 2. X is now equal to 2. It wasn't so bad, was it? This game plan was really going to help you. So pause the video, take a screenshot, take a note. That should help. Last one, we got this. Still grinding, still going to distribute. Still gets us 6x for starters, but now 8y. And this equals 4x plus 12y. I'm going to do the same kind of thing. I'm going to think out where I want. Well, this is kind of tough, and I'll explain why. So now, since we have variables of x and y, I'm going to think out where are my x terms going to go? Where are my y terms going to go? And so I think that's a big thing to ask yourself here is what's going to happen with the rest of the problem. So I see that 6x is on the left side. 6x is greater than 4y, so I'm going to say that I want x terms on the left. And I want my y terms on the right. So I'll split this up. Okay. So that means I would need to move 4x to the left, 8y to the right. 6x minus 4x is 2x. These canceled, 12y minus 8y. These are like terms, they both have y, so rewrite it as just 4y. Divide both sides by 2. We're now left with x equals 4y over 2. But we can actually rewrite this as 4 over 2 multiplying with y, which is really just 2y. And that's equal to x. I hope that this video was helpful. There was a lot here. If you're stuck on anything, please reach out if I can help. Thanks for watching.